Okay, let's try a couple examples. Our first one, I just want to actually go ahead and graph cotangent of x. I know we did this discovery on it, but how would you actually graph it if just given cotangent of x? You're not going to put everything on there that we did on the discovery. You still just want your 5 critical values. So what would those be? Your period is still going to be affected by any number in front of x, and I don't have one, so it's just going to be whatever that full period for cotangent was, which remember is different now, it's just pi. So a full period for cotangent is pi and it hasn't changed. My amplitude is going to be none. Remember, I can't measure distance from the middle to the top or bottom. Domain and range we'll come back to. So I'm not moving left or right. I'm going to start right at 0, and I'm going to go on full period, which brings me all the way to pi. Again, you need 5 values. I've got 2 so far. I still need to have 3 more on my graph. So cut pi in half. We're at pi over 2. Cut pi over 2 in half. You're at pi over 4. In between pi over 2 and pi, we are at 3 pi over 4. On the the y-axis, go up to 1 and go down to negative 1. Still think about the amplitude, the number in front of cotangent, which is just 1. And again, we don't have an amplitude, but it's still going to be that number, that value that sits on my y-axis. Okay, now we're ready to graph. I need 2 asymptotes for cotangent. If you noticed from the beginning, we had a couple asymptotes sitting there. So at 0, you're going to have an asymptote. Cotangent will always start with an asymptote, and then it will also end with an asymptote. So starting at first value, plot an asymptote. Starting at that very last value, end with an asymptote. And then halfway in between is where you're going to get the very center point. So at pi over 2, you're at 0. Then your cotangent graph heads up towards the left. So at pi over 4, you're going to be up at 1, whatever that amplitude number was, that a value. And then at 3 pi over 4, you're going to be down at a negative 1. And then again, please do not connect them in a straight line. It needs to be curved. It's easier actually if you start from the middle and then send that line curved straight up. And then start in the middle and send that line curved straight down. And there is my cotangent graph. Okay, coming back to our 2 other pieces of information, your domain. Remember, that's all rails except you have restrictions. X cannot equal. Pick an asymptote. I'll go 0. Plus the distance between your asymptotes, which again for us is an entire period, so it's pi n. Or since it's kind of silly to write 0 plus anything, I'm just going to get rid of the 0 and say all reals x cannot equal pi n. Or pi plus pi n. Doesn't matter. Your range then, remember that's all the y values that we're getting out, and we're getting everything and anything out, so it is all real numbers, all the way up to positive infinity, all the way down to negative infinity. Okay, there's your basic cotangent. Now let's move it around a little bit. If you flip to an example 4, negative cotangent for x. So I have a negative, that's going to reflect the graph, so we'll talk about how that changes it. And I have a 4 in front of x. Remember, that's your b value, that changes your period. Well, how did I find my period for the past 4 graphs? We took 2 pi and we divided them by b. Why did we pick 2 pi? Because that was the full period for sine and cosine. That was the full period for secant and cosecant. The full period now is not 2 pi, it's just 1 pi. So I'm going to take that full period for the graph at hand, which is cotangent, so therefore it's pi, and I'm going to divide it by b, which is 4. So now my period is pi over 4. I'm not shifting left or right, so I'm going to start at 0, and I'm going to end at pi over 4. Okay, halfway between there is going to send me to pi over 8. Remember, when I cut a fraction in half, the denominator doubles. Cut that in half, I'm at pi over 16. Instead of averaging these 2 points here to figure out my 4th value, I'm just going to look at my increments. This was 1 pi over 16, 2 pi over 16, 3 pi over 16. Okay, my highest value that I'm going to plot is a 1 and a negative 1, again, off of that amplitude value, or your a value. And cotangent starts with an asymptote, and it ends with an asymptote. Then you only need 3 points to plot in between. Pi over 8, or whatever your middle value is going to be the center. And then my last graph went up to the left and down to the right. Because there is a negative here, it needs to reflect. So instead of going up to the left, it's going to go down to the left. Instead of going down on the right, it's going to go up to the right. So that's what a negative will do. It'll make it reflect again, across that x-axis. And there's my cotangent graph. Let's come back to the other pieces of information about this graph. Amplitude, again, we don't say we have one, it's just none. Domain, all reals, but x cannot equal. If you don't like picking 0, pick a different asymptote. I'll do pi over 4 this time. Set pi over 4 plus the distance between your asymptotes, which is in full period for cotangent, so it's pi over 4 n. Your range is all real numbers. Okay, let's go ahead and do just one more. We'll do example 5, so scroll on down to example 5. And this one is 1/3 cotangent x minus pi over 4. I have a horizontal shift happening. This right here is telling me that I am going to the right pi over 4. Okay, so that means I need to shift everything over and start my graph at pi over 4. Where am I going to end my graph? Well, 1 full period away. What is 1 full period for this graph? I don't have a b value besides 1 sitting in front of x, so the period is just going to be pi. It hasn't changed. So if I'm starting at pi over 4, I'm going to add 1 full period, which is pi. Go ahead and get common denominators if you need to. I'm going to end at 5 pi over 4. Okay, we need 3 more values, so we're going to add those 2 values. Pi over 4 plus 5 pi over 4 is 6 pi over 4. Cut that in half, it's 3 pi over 4. Need another one. 3 pi over 4 plus 5 pi over 4 is 8 pi over 4. Cut that in half, 4 pi over 4. Well, that reduces to just pi. Okay, and then one more. 1 pi over 4 plus 3 pi over 4 is 4 pi over 4. Cut that in half, it's 2 pi over 4, which is just pi over 2. Okay, y-axis, this time I do have an a value. It's a 1/3. Again, my amplitude is none, but that 1/3 does affect when I start to curve on out, and this time it's going to be at 1/3 and negative 1/3. Okay, we need some asymptotes. So again, I've shifted everything, so the asymptote is not the y-axis every time. It's wherever your first value is, pi over 4, and your last value, 5 pi over 4. I'm going to get rid of this math we did before so you can see the entire graph here. Okay, cotangent. You need to start that center value right at 3 pi over 4. I haven't shifted up or down, so that hasn't changed. Okay, it's a positive cotangent graph, so we're back to the original. Going up to the left at what value? Well, that's our 1/3. And going down to the right, this time at negative 1/3 at pi. Okay, and then I'm going to go ahead and connect this again in that curved pattern. And there's your cotangent graph. Okay, let's finish filling in the left-hand side. Your domain reads all reals except x cannot equal. Pick an asymptote. This time 0 is not an option. I'll start pi over 4 plus what's the distance between your asymptotes. Again, don't bother trying to count from the picture. Look at your period. And it is just pi n, the entire distance of a period, n number of times. And your range goes on forever in both directions, so that is just all reals. That is sort of your easy one now to fill in for tangent and cotangent, and it'll always just be all reals. Okay, those are a couple examples for cotangent. Then tomorrow you will work on your homework for cotangent, which has 7 different graphs, using these same ideas to practice.